everything is working. Let me know, somebody in this chat or everywhere, if you still got the picture, if you got everything else. Now I see that we're using bitrate, we have encoded frames, it should be fine. Great, let's get back to business. We were talking about integration testing and what it means. It's mostly a white box term, sort of ish, but I don't want to spend much time on it. I much more would like to speak about scenario testing, which is using different usage scenarios that are followed through whilst testing it. It's again an umbrella term for guiding. I can't spell the word umbrella testing term for guiding the testing using figured out usage patterns that are followed throughout whilst testing. Say shoppings for specific item, we have search for from the promoted promote product list, and but we can vary it up with more details, so they are not static. Using different products to find, or adding terms to the users that are in the scenario, like building up on them, like saying, okay, this is a colorblinded user, and how does he do things like, oh, well, somebody who doesn't have a mouse with a right click button, it doesn't work. Can he be able to use our software or not? Need to know. Well, we'll miss problems in non-usual situations. We'll not focus on input data ranges, because we'll use the normal areas and stuff like that. We will not focus on security. There's an E in it, security, or background tasks, or some similar things. And best thing to note and remember is that we might not know all the ways our users like to use our product. Ways our users like to use our product. Simple, nothing bad about that. There's an error correction testing, dot in that, which is nothing more than testing to claim that an error has been fixed. This means testing the error report and the errors around that, and errors related to the fixed error, related areas as well, and trying the same problem in a bit different way. Well, we need to know that it's very hard to say problem is fixed if so you see, the problem is fixed if it's an intermittent problem. Do we know it is fixed? We might not know related areas, and investigation of that might take some time. But these are the things the error correction is, and you should be aware of that. Okay, there's a term like manual testing. I guess it has come from automated testing to be a sort of versus to that. So we have automated testing and manual testing. Manual testing is a bad term. It refers to manual labor, which it means like kind of have the implicit idea it's laborious and boring and something like that. But it actually means a human testing, and actually skilled human testing, opposite of automated checking. This means skilled testing, skilled doing the job. It's an umbrella term again. Well, we need to know that although this is very good, usually it's better than anything else, but routine tasks are better done by computer. As people do things a bit differently every time. They're not doing the same things all the time, and they might be tired and not notice all the specific thing we're looking for. Because there's much more inconsistency between test runs. But this doesn't mean that it's bad. It's just bad in specific cases where we need to, when humans have problems. But skilled people get around this. Get around these problems and are actually very good. So what else do we have? We have a risk-based testing. Again, umbrella term, meaning that our test prioritization is done via understanding and analyzing the risks, both technical and business risks. Usually, if risk-based testing is talked about in the world, they use some sort of documentation and assigning weights to risks, and then using some math to figure out what's the things that we really need to base our testing on, which are the most important things. So we trust in the math and our assessment of the risks, what it's doing. So need to know comes exactly from there that our less risky areas might have big problems that we don't test, that we hope that our assessment was correct, that our math is not failing, and thus we're not having bad coverage of the product. And the math can be very simple or very advanced. I've seen things where risky areas are assigned like 5 different attributes, and then it uses big calculations and stuff to figure out what we should test. And I think we might spend too much time on it. Spend too much time on creating that data that we should have actually used on testing and been better off from it. Equivalence class testing, I'll just shorten it. It's the sort of same thing as domain testing. There is similar to domain testing. There are some technical differences that domain testing should be above it, but I haven't seen much of the difference. I think I'll give a link later on where you can investigate it more further and see what it is and what it's not. So right now, just go to domain testing and you get the information from there. Regression testing, yay, fun. It's sort of similar as error correction testing. It's thought of that it is similar, though there is a important difference. When error correction testing means testing that this thing is fixed and not bad changes have been done because of it. Regression testing is because that focuses around that error, but this doesn't mean specific error corrections, but any change has not regressed our product product and thus we test around the changes and a bit, and yeah. Wow. So we test around the changes that has been introduced into our system. You can test it any way you like. In that sense, it's an umbrella term. Umbrella. I'll get it correct eventually. But it's an umbrella term. We can use it any way you like if we're doing the regression testing on it. Need to know. I'm blabbering. I'll take a sip of water and I'll be fine later on. So, regression testing. We're testing if our latest changes have not made anything else broken in our system that we didn't expect it to affect. Because we don't know all the changes. Because the developers usually don't tell us if they make really small changes in the software. They'll just say the big ones, or we don't know the scope of the changes, or what it might have an effect on. So it's hard to do this regression on everything, but it's a good thing to use every now and then regarding the areas that have been touched. Spec-based testing, based, not testing, based testing, means just testing to make sure that everything has been spec'd works as spec'd, that what has been spec'd works as spec'd. It's a sort of confirmatory testing, and well, it's obvious that we won't see things that are not spec'd. And it's easy to also miss things, miss bugs, if we focus on showing that stuff works rather than looking where it is not working. Scrolling a bit then. And of course specs might be wrong as well, so that's another worry, but it's a bit different thing. So it's easy to get lazy when we just do the spec-based testing. We don't have to think, oh, this needs to be this way, it says so in spec, check and done, and that's about it. I want to touch on tour-based testing. Tour-based is a sort of way similar to the scenario-based testing, but it's again an umbrella. And you can easily imagine it as a tourist in a foreign city can use a organized tour to get around the city to see its sights, or it can break out its own map and wants to see whatever he likes to find, or he can use both, or he can ask from passers-by if there's something to look for. It's a different ways of getting through our product and getting to know the product. Different tours around our product. For example, we could use following documentation. This is also spec-based tour then, or we could use complexity to go through the most complex thing, try and analyze what to do, or follow the error messages. Not the yellow brick road, but the error messages, and to see if we can see our problems and the product in a different light like that, and find more things about it. Well, need to know is kind of obvious. We might choose wrong tours, and that's a train, by the way, if you didn't hear that. Tours not covering the product the way we like. Enough, let's say enough. And well, we'll miss some coverage that we would actually like to do, but we didn't think about that and so on. But it's a good way to do it. It's a good way to figure out what can be done with the product. Then there's how much time I've used. I've used a lot of time, 45 minutes already. I'll just do a few more and then I'll stop. I'll talk about pair testing. Pair testing. I actually would say it's a paired exploratory survey. I think it's the best way for talking about pair testing. Paired exploratory survey, the way James describes it, is that it's two testers on a product, two testers on a product. One is a driver and the other is a navigator, where the driver does the testing, driver open-ended testing, and the navigator guides him or guides driver through the product and documents as well, because he has his hands-free. Documents as well. It's a good thing. I'll just say one more thing. It's usually used for learning the product quickly. Learning the product quickly, preparing for formal testing, etc. So need to know. So we could use it actually the way that somebody is teaching another guy how this product works, what it is, and so on and so forth. So it's not just testing the product, but also giving, sharing the knowledge about the product and some of its quirks and things. What we need to know, it's easy to fall into the trap that it's two people behind the computer, so they'll test efficiently. That's not it, but it works. Trap of just two persons behind the product. It's not that it needs some skill from the navigator, who should usually be more experienced to guide the testing, to make it on the spot, so it actually be effective. Navigator, be experienced, and but this also puts a stress on the testers. So depending on how people handle the stress and working with other people and doing many things at the same time, it just can't be done 7 days a week, so on, because people just can't manage stuff usually like that. And of course, testers need to respect each other. Otherwise, it just doesn't. Otherwise, it just doesn't work. They won't get anything useful out of it. They'll just picker around. I'll skip some of the things because it's getting really long. Yeah, of course, we'll talk about boundary testing. Yes, boundary testing is a very well-known term. ISTQB loves it, and it usually says that it's a term for testing the input data limits. Yes, I agree. It's testing function, input, data, output, etc. Regarding its limits, but also its invisible limits, invisible boundaries. So it's not only about what the user can input, but if the user inputs more in some other way, does the system handle that? Or if there are any sort of hidden limits in the valid range of the data. Like, let's say, need to know again. Knowing the invisible limits is hard. Let's say in a computer system, in a web server system, text goes on, no problem, everything's fine. It doesn't go over the character limit, it's fine. But what about encoding? Does your server handle the same sort of charset that your browser and the user is using? If it doesn't do the UTF-8, then it's an invisible boundary for the text, sort of thing. So these kinds of problems, and or the database behind the PHP server, PHP server that handles data, does again use some other encoding. So the data gets translated from one to the other, and so on and so forth, and you'll miss invariable. You miss some characters that are might be important for users if they are writing in simplified Chinese or whatever, any language that you're not usually using. Knowing the invisible limits is hard. What else we say? Because they are invisible, like third-party DLLs, server configuration, config, etc. And it's easy to miss them, miss those boundaries, and easy to get false sense of security. So this was boundary testing, white box testing, black box testing. They're on opposite side of the gray box, where white box has everything with the product. Code is visible, you can see everything, you can get everything, but you're mostly testing to code, and it's the same as static testing. You get perfect code, but not the perfect product. In black box, it's the opposite, meaning that you don't get any information from the product, but you don't know anything about it, what's going on inside, meaning you won't have enough information to base your tests on, but you can still test it, no problem. You see just what the users will see from it, but just you won't find as much information to give back to developers when something goes wrong, so they'll have hard time in investigating and fixing problems. Well, there is scripted smoke testing. Let's go quickly over that as well. Usually called smoke testing or sanity testing or whatever. It's just quick run of the whole functionality of the product to see if there are any major problems. Any major minor problems. Usually takes like 1 hour or so, depending on the project and some things like that. Of course, you need to know that it doesn't find anything, everything, misses details, misses problems with continuous usage. If there's memory leaks that build up in later stages, then it doesn't find these kinds of problems. And if you have multiple configurations, then you can only test some, and you don't know how it works in other configurations. Let's say operating systems, you have several that you need to support or whatever like that. State transactions, unit testing persistent, and load testing. Load testing not so much. Security testing. Let's talk about security testing a bit. Security testing is again umbrella term. There aren't actually so much techniques to test. There aren't real guidelines or real how-tos how to test, but guidelines how to focus your testing on different aspects of the product. These are actually most of these things. You have to figure out how exactly you're going to do that in any current focus. Security testing means that testing if anybody can get access to any prohibited areas, getting access to prohibited areas, and it could involve a lot of things like session hijacking or SQL, Python injects, or cross-site scripting, or denial of service attacks to make the product slower or whatever, or information, or something like that, or even brute force password guessing. All sorts of things, very much things to do. What we need to know about these things is that the more secure the systems are, more more complicated they are to use, meaning more secure systems are less usable. So the users complain that I have to fill in so many passwords all the time and choose things like that, and then they complain because everything can be broken into. So it's, you have to find a balance on the project side, of course, on this. But it's a vast area to test, and you need to know when to focus and when to stop. When to stop. And you have to remember that every big system, every complicated security system has one vulnerability, which is its users. So there's something need to be done on that, rather than just understanding what's going on. But testing security is a very big thing, meaning that there are very many different areas to look into. You just have to make sure you go read a book or search from the web, talk to the experts how you can do some things, because every system has its vulnerabilities due to its basing or using other products as well, and thus having built-in vulnerabilities from other systems. And I just can't tell you how to test these things. You have to look them up every time yourself. There's well concurrency, confirmation. I won't talk about them. Because we've been talking like over 50 minutes now. Let's sum it up. Conclusion. Saying that what the techniques are, test design techniques aren't only how-to techniques, not how-tos, but guidelines on how to test the certain things. Some of them are approaches, which are these umbrella terms, umbrella. It's just a word that cannot be typed any time at all, which focuses, drives the focus of your testing. But of course, techniques need skill to carry through. You need to understand that there are some things you have to do with them. You have to understand what it means. It's just say that, oh, I'm doing smoke testing, and just running around doing nothing really important things in product. It needs skill. Can be, most of the techniques can be used exploratively or scriptedly. I mean using test cases and such, or of course in between, which is probably the best idea ever, because you'll get some traceability that your project managers like, and you'll get to explore around and find the things to do. The most important thing to know about any test technique, or actually anything you do in testing, is constantly asking how this might fail, or what will I miss with this, or what kind of problems I don't find, or should I spend so much time on it. If we keep this in mind and ask ourselves the same question all the time, we'll be better testers. If we know this, we won't be fooled. Not fooled, and will think critically about our testing. We'll not miss much areas, and will be better testers in the end, because we can use this information in next projects as well. Good. We're getting to the finish of this episode. Just if you want more information, because this has been really crash course, then go to the BBSD site on testingeducation.org and test design, and look at the course slides PDF from there. It's a very good PDF on all the test design things. You get a lot more information, a lot more details on it, what these things are, what can be used, and they also say when these things are not so good and what you need to know about specific design or something like that. There's another good thing, another good read is the little black book on test design. I'll post the links in the web page as well on testosthours.com, so you can find it from there. And this is it. Next week will be peer conference in Tallinn, the second one, PES 2. So I'll be there, and I won't make another episode, or the week after that as well. So I'll be too busy doing other things. I hope you enjoyed this. I hope this has been useful to you. And next episode, I think, will be a bit more fun. We'll cover some product testing, or somebody else's testing, or do something else, which is not just me talking and filling in a mind map with typos, which might be not so fun to look at and listen to. So thanks for watching, and go to testosthours.com. Testosthours Live is there, and you can get all the information and archives information from there as well. You can send in your questions to live@testosthours.com, and we'll can approach and answer those questions in the next episodes. So thank you for watching. Good night.